Hello, and now Anke here from the Folke Center. I'm working with the data collection here and the techniques set up here at the Folke Center. So this is just a short review what I am planning this winter to collect some extra data for, because the market is going the battery solution. And now we talk about small wind turbines. Here at the Folke Center, we have 3 wind turbines who is connected for a grid solution. We have at the one with the tiny house, a leading edge 450 watt wind turbine who is connected directly for off-grid system. And there's a battery solution. This is a direct 24 volt charging directly on the battery, and in the tiny house there's an inverter who supply whatever they use the power for. Then we have the proven Kingspan, Ryse or whatever, 2 kilowatt wind turbine who is connected for a battery system who is grid connected, and include a PV system, as Bornai was talking about, to see how much we then use the battery when we have a setup, we have the boat. And then we have AC coupled directly wind turbine 3-phase who is connected for a battery system too. The direct couple in the straw house with PV system is quite simple. It's the most common way to do it. As you have a DC wind turbine, 48 volt, connected for a controller, charged directly on the battery. It's a normal lead battery system, 16 kilowatt hour, I think it is, and with 2 volt cells, and automatical water filling system, and an air outlet. And there is a PV east-west system on the system who is delivery power on the DC. Then there's a Victron inverter who is supply the house with electricity or energy, and when the battery is full, it's delivery the energy for the grid, so we can use it. Here is more simple drawings how it function. The wind turbine is charged directly on the battery. The controller for the wind turbine has the features is if the inverter not take the energy and the battery voltage go more than 60 volt, then it clamp in 2.5 kilowatt load who take the wind turbine down. Instead of short circuit the wind turbine to avoid freewheeling, then it take down the RPM, so we know where we burn the energy. If we short circuit, then we can the risk is to burn the generator, because if there come a heavy storm, now I have control over it. And then in the inverter, yes, if it's not if the grid are gone, then it can there's an output who can, if the battery voltage is more than 59, we burn it as heat. This system we don't directly have here. It's a PMG direct couple on the AC side, and it will be like this. But we have an Ashicon, as I talk about, and I think it's like I think it was Bernie who talk about when you come up in size of a wind turbine. If you have a battery PMD 48 volt, you have a limitation in current, how much energy you can take from the wind turbine on the battery side. So it can be some problem. And here we have a setup from together with Victron, who is a 3-phase system, 3 inverters, who from the wind turbine make a grid. If it's off grid, it run off grid. And I would rather take the next one to show more how it was made. The normal AC coupled wind turbine has something which is called frequency response. Has a frequency response And that's a normal controlling system in a grid-connected wind turbines today. So if the frequency go up, it go down in power. And if lower, it produce whatever it can. And the inverter has the function, normal to have the function, who is the same in the battery is full, automatically set the frequency up. And it has, if it grid connected, then they deliver the power for the grid when the battery is full. So all own consumption will be. Yeah, again, the same one, AC directly, to show how the inverter was. There is an output, relay output. So what I do now to the first test is only a test. I have run the first test is how it works when it's own consumption. It's grid connected wind turbine with batteries, like the one with PMG in the straw house. Here, if the grid are gone, or I disconnect the grid with 90% charge of state, then I'll run directly on the battery. And if I have not connected the heater, else there is directly in the inverter, there is, so we can connect the heater if the battery is full, or else it's the benefit. What I see, what I want to test together with Victron, is that if the DC has to charge on the battery, then the inverter has to deliver all the power through the inverter and up on the grid. If you direct couple the wind turbine on the grid, you have the consumption directly. So you not have to convert. The only thing the inverter has to do is to balance the wind turbine. And you can put PV on if you want to. And as we had talked about with the straw house, if we have sun and PV, not sun and wind, and there's some consumption, we don't use the energy of the battery. So we not use the capacity of the battery. And I can see, yeah, it's quite well. And if there's no wind, then I have the same as we see when there's a load on. We use the energy in the battery in the night, and then we charge, and then we run on the battery. And we need a huge battery capacity if we have day without sun. So if we have wind turbine, we can have less battery on it. And now we have another, what I start with the first one who was here. I have the question, what is the issue with the direct coupled wind turbine? There's different way we can talk about this back-to-back inverters and there's direct coupled. Is the wind is very fluctuating. There is only 1 minute of data. And you can see there's very fluctuating. It's a small wind turbine, a tandem wind. When in low wind, when there's wind enough, no problem. But with low wind, you see sometime when the wind is dropping to 2 meters per second, we're consuming energy. Maybe it's better to stop the wind turbine is to find a solution where it's to balance. But I have tried to disconnect the wind turbine. Then the rotor is dropping in speed. And when there is wind again, I have dropped the speed in the rotor. And then the first wind, who is coming in few seconds, need to drag the wind turbine up in speed again. And the energy I lose in the rotor, it's not worse. If I just keep the generator on and use the battery to spin it, I have the speed in the rotor, the tip speed, so I have the efficiency in the rotor. It could be a good idea to keep it on. And this is something we have to experiment this winter when we have some wind. And as this one is the same again, I have here where there's a consumption of energy, and then I stop the wind turbine. There's a load on the wind turbine because the brake is there's a negative brake on it, and there's a computer. I have some extra stuff in the wind turbine, so it's use a little more. And then the rotor speed come up again, and then it consume, produce. Yes. And we see the same here again. When there is no wind, here's the wind speed. When it's below 4 meters per second, there is no production. And then we dropping. Then there come a little wind, charge a little, and then the balance is. And when suddenly comes some wind, yes, now we have charged the battery, because the wind turbine is very aggressive when there come wind. And then we think, okay, this is the issue with the battery. I have to take a thermal to see where is the energy loose in a inverter system. The battery is cold, battery is no problem. The inverter, always the electronic switching, what we have had talked about before today. When you have a switching, then we can see something who is very hot, is the controller. This is no problem. And then the talk was, is battery storage worth it? I would say here in Denmark, maybe Norway, a different country, there will be something, the electric price go up and down. Now we have a couple of days where the electric price is zero. Then it's better just to buy the energy. And when like tomorrow, I know, or was it today? It was yesterday I made it. I can see this evening, it go up to, is it more than 6 kroner per kilowatt? Then it's good to have the battery. So if there is a payback on a battery storage system in a normal household, PV, solar, we always need is a good payback on. But if the battery in itself, because of the price running, could be an investment because the battery is dropping in price, then we are very close, because then the wind turbine is the thing you need, like Bernie talked about, to the capacity of the battery. Because if you don't have the wind turbine, then you need a huge battery capacity in the winter time. It's something I will work on this winter. So it was only to tell about what is I will work on here together with Victor and 3 wind turbines. And that was all what I would talk about this time.